free fall. All objects moving under the influence of gravity only are said to be in free fall. Free fall does not depend on object's original motion. Basically, if you drop an object or throw an object downward, the motion of the two objects will be different, but free fall properties will be same. So say you drop an object downward. So in this case, the initial velocity of that object is 0. So since initial velocity is 0, after 1 second, the velocity of that object will be 9.8, which is mainly acceleration due to gravity. So the velocity of that object after 1 second will be 9.8 meter per second, and after 2 seconds, just double of this, and after 3 seconds, that's 3 times of this 9.8. Okay, so this is the basic properties of free fall. But if you throw an object, okay, in this case there is an initial velocity. Okay, say the initial velocity is 10 meter per second. Okay, then after 1 second, the velocity will increase 9.8 meter per second. Okay, so after 1 second, the velocity will be 19.8 meter per second, and after 2 seconds, just if we add 9.8, the value of after 1 second, then after 2 seconds, just we add 9.8 meter per second. Okay. So in this case, the properties of the free fall remain same. Okay, if we drop the object or if we throw the object, all objects falling near the earth surface fall with a constant acceleration, as I discussed here. The acceleration is called acceleration due to gravity and denoted by small letter g. Now, acceleration due to gravity. So let us consider an object with mass m is falling downward. Then from Newton's second law of motion, you can write down that F is equal to ma. So F is a vector force vector, okay, and acceleration is also vector, acceleration vector a. Now here the force is basically the weight or gravitational force, okay. So it's mainly downward, and if we take y-axis upward and positive, and uh, the downward is negative, okay. So the force is mg, magnitude is mg, and the vector basically this is downward, so that's why the negative j, y-axis and downward, so that's why the magnitude of the force is mj, but for vector we need to just add minus, so we need to multiply minus j. So the force is minus mgj. Now if we put the value of force, minus mgj is equal to ma. So from this, acceleration a equal to minus g. Okay, so acceleration due to gravity is g, which is equal to minus 9.8 meter per second square. So it is always minus 9.8, minus indicated the downward. Okay, and the value the value of the acceleration is constant, is 9.8. So sometimes we just use g equal to minus 10 meter per second square. Okay, so g is always directed downward, as I said earlier. So downward means towards the center of the earth. So ignoring air resistance and assuming g does not vary with altitude over short vertical distance, free fall is a constant acceleration motion. Okay. Now, this figure shows free fall of an object in case of dropping. Okay, so in case of dropped an object, initial velocity is 0, upward direction is considered positive, and downward direction is negative. So acceleration g equal to minus 9.8 meter per second. In this case, equation of motion is can be equation of motions can be written as replacing x by y, where x is x or s, mainly s replaced by y, and y will be negative. Replace acceleration by minus g. Okay, so if the equation is v is equal to u plus at, then v is equal to u minus dt. So where a replaced by minus g. And if the equation is s equal to ut plus half at square, then s, in case of s, is just minus y is equal to ut minus half zt square. Okay, so just we replace s by y minus y because downward movement, and acceleration by minus. Okay, now in next figure, that is the free fall and object throw downward. Okay, thrown downward. So in this case, thrown, there is an initial velocity. So the velocity, initial velocity is not zero. Okay, but this initial velocity is downward, so that's why the initial velocity is negative, because we said earlier that the upward direction is positive y and downward direction is negative y. So that's why the velocity is along the negative direction. So the velocity is also negative. Okay, and acceleration is downward, so that's why acceleration is also negative, which is minus 9.8. So here acceleration is always constant. Okay, and in this case, in this figure, mainly free fall object, okay, thrown upward. Okay, so this is vertically upward. Okay, not making a particular angle. In this case, initial velocity is upward, so the velocity, initial velocity is positive. Okay, and at the highest point, the velocity is zero. So from initial velocity is positive, then it's decreased due to the gravity, and just velocity, just after decreasing the velocity will be zero at the highest point. Okay, and here is also acceleration a equal to g equal to minus 9.8 meters per second. So everywhere in the motion, g is always minus 9.8 meters per second square constant. Now projectile motion. So projectile motion is the motion of an object thrown or projected into the air, subject to only the acceleration due to gravity. Okay, so the object is called a projectile. To describe the motion, we need to introduce two-dimensional coordinate system. Along the horizontal case or horizontal plane, we consider positive x-axis, and along the vertical plane, we consider the y-axis. Now, in first slide of this lecture, mainly of this top part, mainly we see that acceleration is equal to minus 9.8 j. So acceleration has only y component, and the x component is zero. So there is, since there is no I component. Okay, so our x component is zero. So you have to remember that acceleration along the horizontal plane is zero, and acceleration along the vertical plane is 9.8, which is always downward and negative and also constant. Okay. Now, figure shows the motion of an projectile, where initial velocity is denoted by v naught. So this v naught is the initial velocity vector. Now, if we throw an projectile in vertical plane, basically upward direction, not making just angle is with positive axis is 90 degrees, so vertically upward. Okay, perpendicular mainly. So in this case, the mainly the projectile motion is depend on the initial velocity v naught, and mainly the acceleration due to gravity. Okay, but if we throw an object making a particular angle with positive x-axis, here just the motion or trajectory of the object depend on the angle also. Okay, and also the time. So v naught, this is initial velocity vector, has two components. Horizontal component is v naught x, which is equal to v naught cos theta naught. So here v naught is the magnitude of the initial velocity, and theta naught is the projectile angle. Okay, and the vertical component is v naught sin theta naught. Okay, so it's basically the component of a vector I described in the vector lecture in the vector. Okay, so here theta naught is the angle between the x-axis or horizontal plane and initial velocity vector. Okay, v naught. Now, what does the trajectory look like? Okay, So figure shows the trajectory of a particle and also the components of the velocity vector. Initial velocity has component vix and viy. You can also write just v naught x and v naught y. It's totally up to you. If you just take initial velocity v naught, initial velocity vector v naught, then the component will be v naught x and v naught y. And if you take the initial velocity is vi, then the component will be vix and viy. So it's totally up to you. Okay. So velocity vector at a particular time t is v, and the components are vx and vy. So we know that x component or horizontal component of acceleration is 0. So since acceleration is 0, then the x component of the velocity is constant, because if we differentiate the constant, then the answer is 0. So the differentiation of velocity gives the acceleration. So that's why acceleration is 0. So the velocity is constant along the x-axis. So from figure, it's clear that x component of velocity is always constant, okay, and equal to v naught cos theta. Okay, along the y direction or vertical direction, due to gravity, velocity component along the y-axis changes with respect to time. So at height mainly highest point mainly y component of the velocity vector is 0, as shown in this figure. Before the highest point, component y of the velocity, okay, is positive, and after the highest point of the trajectory, y component or particle component of the velocity is negative. So at the highest point, velocity y component is 0. So from this information, you can easily say that the object passed the highest point or not if the velocity vector is given. For example, if the velocity vector is given, say v equal to 3i minus 4j, okay, so here x component is 3, but y component is minus 5. So the velocity y component is minus 5, which is negative. So the object passed the highest point. So if the y component is positive, it does not pass the highest point, and if the component is 0, then it's in the highest point. Okay, so here is the equations of motion in projectile. Okay, so in projectile, just we need to divide it equation in two parts. One is along the x-axis and along the y-axis. So in along the x-axis, motion is uniform. Okay, because here I already discussed earlier what is uniform means. So along the x-axis, here acceleration is 0 and velocity is constant. So that's why you consider this uniform motion. But along the y-axis, the motion is accelerated. Okay, so changing with respect to time. So first acceleration, here acceleration is 0 along the x-axis, and along the y-axis is minus 9.8. Okay, which is constant. So along the x-axis, first velocity equation is vx is equal to vi cos theta. So here vi is the initial velocity and magnitude mainly, and theta is the angle between x and vector vi. Okay, so y component here vy is equal to vi sin theta minus gt. So here vy is changing, the y component is changing with respect to time, but x component is always constant, vx equal to vi cos theta. Okay, so at any particular time, x component of the velocity is always constant, and the value is vi cos theta, but y component is changing, vy equal to vi sin theta minus dt. And then displacement, so along the x-axis, displacement is denoted by x. So x is equal to vi cos theta into t, and along the y-axis, you can write down the by y, or you can write down by h, because this represents the height. So vertically, the displacement h is equal to vi sin theta t minus half gt square, and the maximum height h, capital H mainly, or H max, is equal to vi sin theta square divided by 2. So you have to remember these equations, okay, to solve the problem. Okay, So basically, these are the similar to the equation of motion in one dimensional case. Here we just replace velocity by its velocity component, and just acceleration by acceleration along the vertical plane, along the horizontal plane, and also the s is replaced by x or h.